on to question number 2. A particle P moves in a straight line at time t seconds after leaving a point O on the line. P has velocity v, where v is equals to 44t minus 6t squared minus 36. Now in this case, the velocity time graph would look something like this. Now since the coefficient of t squared is negative, the velocity time graph will look like this. Now part A, find a set of values of t for which the acceleration of the particle is positive. So we know that the gradient of the velocity time graph is the acceleration. So that means when we differentiate this equation, we will get acceleration. So let's write it. So this will become 44 minus 12t. So acceleration of the particle will be positive when the gradient of the velocity time graph is positive. So we can tell that in this graph, the gradient of the velocity time graph will be positive until this point. Over here, the acceleration will become 0. Over here in this part, the acceleration will be less than 0, and in this first half, the acceleration will be greater than 0. So if we find out the value of t at this point when acceleration is 0, we can say that when time is greater than 0 and less than this point, the acceleration will be positive. So for this, we will need to equate the acceleration to 0. So let's do 44 divided by 12, which is 11 over 3. So that means that when t is equals to 11 over 3, over here the acceleration is 0. So that means that from t is equal to 0 to t is equals to 11 over 3, the acceleration will be greater than 0. See, as the gradients will be greater than 0. So we can write the final statement like this. Acceleration of the particle is positive when, you can write it like this. So for part B, it says find the two values of t at which p returns to O. So we are told that this is the formula or the equation for velocity, and we know that whenever we integrate velocity, we get the displacement. Now why do we need the displacement? This is because they're asking us to find the time when p returns to O. So point O is the point of origin. So that means that whenever the displacement is equal to 0, those will be the times when the particle p is at its point of origin. So let's integrate velocity. So when we integrate 44t minus 6t squared minus 36, that will mean that displacement is equals to 44t squared divided by 2 minus 6t cubed divided by 3 minus 36t plus c. So we know that the point P starts from the point O. So that means that whenever t is equal to 0, these terms will become 0. That means that the unknown constant is also 0. So this will become 22t squared minus 2t cubed minus 36t. Now we have to find out when p returns to 0, so we will equate displacement to 0. And now let's use the quadratic formula to solve this. So first we will simplify this like this. We will take t out of the equation and then do 22t minus 2t cubed minus 36. So displacement is 0 when t is equals to 0, or when 0 is equals to 22t minus 2t squared minus 36. So I will simplify this and write it as 2t squared minus 22t plus 36 is equals to 0. So we will apply the quadratic formula on this. So this will become 11 plus the square root of 11 squared minus 4ac over 2a. Oh, sorry, this is 1. So t displacement is 0 when t is equals to 9, and when t is equals to, and now we'll add the minus sign, so when t is equals to 2 and t is equals to 9, these are the times when the displacement is 0. So that means that P returns to O when t is equals to 2 and t is equals to 9.